Now, when it comes to filters, there's one important difference between Power BI and Power Pivot for Excel, and that's that Power BI actually enables you to create two-way or bi-directional filters. So let's take a look at that familiar three-table model, just like we've seen before with one exception. That relationship between territory lookup and sales data now contains a bi-directional filter. So by updating the filter direction in that relationship between sales and territory from single to both, we've essentially allowed filter context to flow in either direction. What that means is that filter context could flow from the territory lookup down to the sales data, just like normal, but it could also flow from the sales data up to the territory lookup, and then from there down to returns. So what we'll see now is that we can control and filter returns data using filter context from within the sales data table, which is something that we could not do using the one-directional filters in the last lecture. So let me show you what that looks like. Here we go, same three-table model. The only difference is that one bi-directional filter between territory and sales. And because we've enabled cross-filtering between those two tables, we can now see correct values using the territory key field from either one of those tables. So again, just like before, using the territory key from the lookup will yield proper, accurate values for both order quantity and returns quantity, since it's upstream and connected. What's new now is that pulling in the territory key from the sales data will not only return proper order quantities as you'd expect, but that filter context is now able to travel up to the territory lookup, which then filters territories based on which ones generated sales, and then that filter context in turn passes down to the returns data table, which filters accordingly as well. So we've essentially created a way to transmit filter context from within the sales data table all the way to the returns data through the territory lookup. Now, as you'd expect, if we pull in territory key from returns, same story as before, that filter context is trapped in the returns data table because we've got that one-way relationship between territory and returns. So let's keep this idea going a little bit and consider a similar model with one difference, which is the bidirectional or cross filter now exists on the relationship between territory and returns instead of sales. What we see this time is that, as always, the territory lookup version of territory key returns the proper values. The territory key pulled from the sales data table returns incorrect return quantities because now that filter context is trapped within the sales data table. But here's where it gets interesting. When we pull in the territory key from the returns data table, the returns are accurate, which we know will be the case, but check out territory key and order quantity. At first glance, things look good, but remember that territories 2 and 3 don't even exist in the returns table. So since no information about territory 2 or 3 ever gets passed up to the territory lookup, then they'll subsequently get filtered out of the sales data table as well. So the filter context that we created by using this territory key field from the returns table is properly flowing up to the territory lookup and then down to the sales table, but in doing so, it's yielding misleading data. And this is dangerous because this type of issue can be very, very difficult to detect, even if you know your data model inside and out. So had we not gone through this exercise, we may never have realized that territory 2 actually drove an order quantity of 40, and territory 3 drove an order quantity of 30. But because of the way our filter context flows, those values get completely stripped out of this view. So that brings me to my next point, which is a word of warning about two-way filters. The fact is you've got to use two-way filters carefully and only when necessary. Now there are cases where two-way filters are helpful or sometimes even necessary. Like for instance, if you want to intentionally filter a lookup based on a data table, kind of like we just showed. But the thing is, two-way filters really aren't recommended for models with multiple data tables, exactly like the one that we're working with. And in fact, if you try to use multiple two-way filters in a more complex model like this, you run the risk of creating something called an ambiguous relationship. because you're essentially introducing multiple filter paths between tables that could potentially contradict each other. So consider this data model shown here on the left. We've got the same three tables that we've been looking at, plus now a product lookup table as well. And you'll notice that there are two bidirectional filters here, from territory lookup down to sales and down to returns. What's important to call out here is that only one of the relationships from the product lookup table to the data tables can be active at one time. If you tried to activate both, you'd see an error message like this. It basically says you can't create a direct active relationship here because it introduces ambiguity. So you've got to either deactivate or delete a relationship or change one of your bidirectional filters to one way. So very, very confusing and not really intuitive at first glance. So I'm going to take a stab at explaining this to you in plain English the best way that I know how, but this is a little bit nuanced, so it might be one of those cases where you're going to need to step back, pause the video, maybe rewatch it a few times before it starts to really click. So here's the deal. Let's imagine that we want to filter our data for a specific product. And to start, all we care about is the relationship between product lookup and returns, which is currently active in the model that we're seeing here. So for the sake of example, we want to filter down our data to just the product named racing helmet. Okay? So that filter context, product name equals racing helmet, passes down, it flows downstream right to the returns table. And as a result, that returns data table filters down to only rows where that racing helmet was returned. Now, if that helmet was only returned in territories 7 and 8, because territory keys 7 and 8 were the only ones remaining in that filtered down returns table, that's the context that gets passed up to the territory lookup through that bidirectional filter and tells that territory lookup table, hey, there are only two territories that exist in the universe, 7 and 8. Now, shifting gears to the relationship between the product lookup and the sales table, let's go through that similar thought process here. Imagine we could also activate that relationship. That way we can say, all right, product name is racing helmet. Let's allow that filter context to flow down to the sales data table, just like it flowed down to returns. Except now this time the sales data table is going to collapse and filter down to only rows showing records where that racing helmet was sold. And if that racing helmet was sold in stores 7 and 8, as well as 1, 2, and 3, then that filter context also would pass up to the territory lookup through that bidirectional filter and tell the territory lookup, hey, there are 5 territories that exist in the universe, 1, 2, 3, 7, and 8. So what we've done in this hypothetical situation is pass two conflicting sets of filter context to that same territory lookup table. The returns data table is telling the territory lookup that the only territories that exist are 7 and 8, and the sales data table is passing along different information and saying that territories 1, 2, 3, 7, and 8 are the 5 territories that exist. So that's what we mean by ambiguity. Both can't be true at the same time, and all we end up doing is confusing Power BI and confusing that territory lookup table in a way that prevents our model from producing or yielding meaningful values. So as a result, Power BI forces you to keep one of those relationships inactive so that you can't possibly pass conflicting filter context to the same table. So at the end of the day, that's really just a long-winded way of saying we don't want to use two-way filters in our particular model. And as a pro tip, rule of thumb, I'd recommend that you try to design your models with one-way filters and one-to-many cardinality, especially as you're first learning, unless more complex relationships are necessary. So with that, let's take a quick peek at what this actually looks like in the Power BI environment. All right, so in the AdventureWorks report, I'm going to start in the report view first. And as a reminder, I've got my matrix here. And one thing that you can do is actually hover over the field that we've pulled into a row list to confirm exactly which version of territory key we're looking at. In this case, we can see that it's coming from the AW returns table. So remember that we've got the key from our returns table, and we're getting incorrect order quantities here. When we jump to our relationships view and we find that relationship from returns to territories, we can double click to edit, drill into this cross filter direction, change it to both, and press OK. See that little arrow switch from one direction to both. And now when we return to the report, this is exactly what we had talked about. So now order quantities look to be correct, and to the untrained eye, the initial reaction is to flash a thumbs up and say, okay, we're good to go. We've got order quantities broken down by territories. We've got returns by territories. But again, remember the problem here is that we are missing data. There are actual valid order quantity values for territories 2 and 3 that aren't showing up because by using territory key from the returns table, we've filtered them out from step 1. So now let's go back to relationships. I'm going to double click that same relationship, change it back to single, press OK. And I'm going to find the relationship from sales to territories. There it is. I'm going to make this one bi-directional, press OK. Head back to report, pull out the territory key from returns, and pull in the territory key from sales. And here's what we see. In this case, we see the correct values from both, but only because each of the 10 territories registered a sale or showed up in that sales data table. So important nuance there. These numbers could very well be incorrect as well had there been one of the 10 territories that didn't show up in the sales data. We'd have the same issue that we just had with territories 2 and 3 in the return table. So last little demo here, back to returns. If I go back to the relationship between territories and the returns table and double click, watch what happens when I try to click both here. I get this error that says you're trying to create an ambiguous relationship. You can only have one filtering path between tables in a data model. So you can't even press OK. You have to deactivate one of those existing relationships, or unless at least one of those filters was changed back to single direction. So for the sake of our model, I only want one-way filters because I don't want to introduce the potential headaches that we just talked about. I'm going to go back to my sales territories relationship, change that back to single as well. There we go. And now just for good measure, let's go back to report, pull that territory key from sales out, and let's grab the proper one from our lookup table and drop it in rows. So I know that was probably a little bit confusing at first. Again, I'd recommend rewatching this a few times until it starts to make more sense. But the one big takeaway from this entire conversation is that for our purposes, we will not be using two-way filters, and therefore we will never pull in foreign key fields from our data tables. So it's going to keep things simple. It's going to keep things accurate. From here on out, every time we filter our data, we're going to do so using fields from our lookup tables.